Hey guys, it's Miss Marfleck here. We're going to do a review of inverses and inequalities today. This review is going to be nice and quick. It's just going to be one problem of maybe each type of topic within these two topics that we've covered. This is really not a video to maybe go in depth on the content. We already have 3 videos on inverses and inequalities, so go back to those videos if you're very confused. But you should, no matter whether you're confused or you're feeling good, you should watch this video from start to finish, because throughout this video I'm going to talk about some things maybe you can expect to see on your assessment. As we've noticed that these assessments, they're online, so they're multiple choice, so there's certain things that I may ask, and you may not see the style of question that you've seen here, but maybe just a type of question that sees whether or not you understand this topic very in depth. The first thing we did was we worked with inverses, and we worked with finding the inverse. And the first type of find the inverse we did was a table of values, which we called numerically. You should know that with a table of values and numerically, to find the inverse, you always switch the x and y. You switch the x and y column, and then once you switch them, now you have the inverse. So this is maybe, the original problem, and I can give you a table of values, a relation, a function, whatever, and I can ask you for, which of the following is a coordinate point that is on the inverse function, and I can give you a point like 2, 7. And then you have to be able to identify out of maybe 4 multiple choice that would be a coordinate point on the inverse function. But you could see here I just switched that x and y table. After we did numerically, we did algebraically. And some people are doing really good with algebraically. And then some people who maybe struggle with those inverse operations need to practice this a little bit more. All these topics can be found on Khan Academy though. First thing we did was take out our f of x and replace that with y. Now you're working here with just the original function. Once you switch that x and y, we talked about how that is now the inverse function. So I can, list this as step 1, step 2, step 3, and ask you at what step are you working with the inverse function. Now this is the inverse function, but you need to solve for y by subtracting 1. And then I need to undo this cube root operation by cubing both sides. And then lastly, I divide by 2. And then now I have this y here, but I don't want that to get confused with the original function that I have in step 2. So I'm going to replace that y with my inverse notation, and then now that's the inverse function. All right, after we did numerically, algebraically, then the next thing we did was graphically. Now you won't be able to graph the inverse, by hand or by scratch, but it's still good practice here, and we're going to graph to find the inverse, and here we are working on number 3, and we're actually going to use the same example, very similar to number 2. We're going to work with another cube root. Now when you're working with the original and the inverse function, you're trying to graph them, you first have to start off by graphing the original function, which is here y equals cube root of x plus 2. So you need to pick values of x, plug them in, and get out a y. Now, for any type of function, you could pick -2 to 2, but when you're working with square roots and cube roots, you have to pick values that you get out whole numbers. So I know I could plug in -8, and I get out a cube root that's a whole number, -1, 0, 1, and 8. All right. And then once I plug in my -8, I get out -2 plus 2 is 0. I plug in -1, I get out -1 plus 2 is 1. I plug in 0, I get out 2. I plug in 1, I get out 3. I plug in 8, I get out 4. And then now this is the original function y, and then when I go to graph my inverse function, all I have to do is switch around those points. And here I'm going to have 0, 1, 2, 3, 4, -8, -1, 0, 1, and 8. And that's a scrap work you do to switch them around. And you need to start off with this, and then you could switch them. And I'm not going to graph it. I mean, I'll just do a rough sketch. The purple one looks something like this. That's our cube root function laying down. And then the pink one is reflected over that xy axis. So I can ask you inverses are reflected over what line, and you'd have to tell me that that's y equals x. But that's what your picture should look like when you go ahead and graph these on a coordinate plane. All right. After we did some work with finding the inverses, after we found the inverse, the next thing we did, I'll put a dotted line here. After we found the inverses, the next thing we did was verify the inverses. And we had a method for verifying inverses, and that was called composition. We started off with the definition, and the definition stated that if you compose f and g together and you get out x, and then you compose the other way, g and f together and get out x, then the two functions you have are inverses of each other. So here we are, we're going to take a look at number 4, and we have f of x is x plus 5 over 2, and then g of x is 2x minus 5. All right, and then now I'm going to use composition to see if they're inverses, and remember the goal is to get out x. Now, if you use composition in the first way, you get out x, you do have to do the other direction and see if you get out x. However, if you compose them and you do not get out x, you don't need to do the other direction. In one of your latest homeworks, the ones before the inequality, I had some people who maybe had this binomial cubed and they spent the time like cubing it all the way to see if you get out x. At whatever point or whatever step you're at that you realize you're not going to get x, you can just write no, they're not inverses. But here we are, we're going to compose, and I'm going to first start off by putting g of x into f, which means I start from my f of x equation, and I have x here, and I'm going to plug this g into where I have x. So there's my g of x equation, and then I have the rest of my f equation. Now, if this is a little confusing for you, go back to the video where we did inverses day 2. I did use some color coding to help. And then now the goal here is to simplify. We have minus 5 plus 5, so that's just going to be 0. And then 2x over 2 is x. So we're feeling pretty good that these might be inverses, but now we do have to go and do the other direction. And when I do the other direction, I'm starting with my g of x equation, and then wherever I have an x, I'm taking it out, and I'm plugging in my f of x equation. And then now I could see 2 over 2 is 1, and then I have x plus 5 minus 5, and that's also going to be x, so this would be a yes. They are inverses. All right, now this is pretty much it. These are the only types of questions we really did with inverses, numerically, algebraically, graphically. This is a rough sketch. Do something a little bit better, but you have the coordinate points there. And then composition we found was a little bit trickier, but you know, also expect maybe some just questions about you knowing what an inverse is. If I ask you, you know, what is the inverse of square root, I could ask you verbally, square root. Well, you should know that the inverse of your square root graph is your quadratic. And that's one of the first examples we actually did together, and we saw that the square root is the quadratic graph laying down. If I ask you, you know, what's the inverse of a cubic function? You should know the inverse of a cubic function is cube root. And that's like this example here, up here. Well, we know our cube root lays down like this, and you know, there's that cubic function that goes up like that. And then we also did just x, inverse of x to the first power, or linear function is linear. Linear and linear. And you can see that here, these functions are inverses and they're both linear. All right, so there's maybe some conceptual questions there. All right, after we did inequalities, after we did inverses, we moved on to inequalities. And I was actually expecting a lot of you guys to struggle with the inequalities, but your homework looked really good. So yay. Maybe some people just figured out that all you have to do is follow the rules, that when the absolute value of x is less than c, your solutions are between negative c and c. When your absolute value is greater than c, keeping in mind that c is a positive number, you have those two splits. And then here's where we get into the negatives. When absolute value, which is always positive, when is it less than a negative number? That never happens. A positive number can never be less than a negative number. And then that absolute value, when is an absolute value or a positive number greater than a negative number? And that happens all the time, all real numbers. And this is something, obviously, you know, these assessments are open notes. This is something that you should have with you when you are taking your quiz. Okay, this is something you should have with you when you are taking your quiz. And you guys are in luck, because in years past, my students have had to memorize and know these rules by heart like Miss Marfleck does. All right, anyway, you could see in all these rules that the absolute value sign is isolated. It is by itself, which means that's the first step, is to get the absolute value sign by itself before you start using any of these rules here. All right, we're going to move on, and our directions are kind of switching a bit, and we're going to go to solve now. The numbering is going to start all over. I know we did 4 examples with the inverses, but now we're starting this new topic, inequalities. So I'm going to start off with number 1 here. And we have 3, absolute value 2x plus 7, absolute value plus 4, less than 3. All right, so like I said earlier, first step is to isolate that absolute value sign, which means I need to subtract 4 from both sides. And I'm going to go ahead and I'm going to divide on through by 3. And then now that that absolute value sign is all by itself, I can peek at my rules and see, okay, absolute value of my algebraic expression is less than a negative number. That is right here, absolute value sign is less than a negative number. This will always be positive. When is positive next less than negative? Never. This is a no solution. No solution. All right, moving on to number 2 here. And we have absolute value signs, 3x plus 4. Plus 2, and that's greater than 10. Same thing, isolate that absolute value sign here. And we're going to have that is greater than, did I say less than? I don't know, greater than 8. All right, greater than 8. And then now we see absolute value of an algebraic expression greater than a positive number. Okay, greater than positive c. That means I have everything inside the absolute value sign is greater than c, or everything inside the absolute value sign is less than a negative c. And then I'm just going to isolate x now by subtracting 4, dividing by 3. That's my one solution. Or I subtract 4 and I divide by 3. Now I said we can write these as 2 separate solutions and then combine them together. I'm going to start with this one first because I'm kind of skipping some work here. So negative infinity to negative 4. And then I'm going to union that with this solution here, 4/3 to infinity. But you could have written them maybe as separate ones first and then just switch them and put them in order from least to greatest. All right, I said this was going to be quick. I'm actually really proud of myself. I usually like to talk and explain things, but you know, we've done all this before, so we're just going to keep going. And we got 2 more examples left. And I'm looking at the time and I'm very proud of myself. This may be the shortest video I've made. But I think you have plenty of videos on this content. You have 3 videos and now you have a review video for a short assessment. All right, so here we are. We're going to isolate that absolute value signs, which means I have to divide by -2. Be very careful. When you divide by a negative, the sign flips, okay? So we do have to flip that sign around when I divide by the negative, and then now I have the absolute value is less than a number, and I can peek back at my conditions, and that's going to be a condition 1 statement where I put it between my 2 c's. So this algebraic expression is between -2 and +2. Remember we said that these rules also hold true for when you have a line under the inequality. Now we have this compound inequality that we're used to seeing with trig, and you have to solve by doing the same thing to both sides. So I have to add 1 to both sides, and then now I'm solved. This is our inequality notation. We're going to go to that interval notation. X is between -1 and 3, and it is inclusive of the -1 and 3. Sorry, you might have noticed a little break in the video. That's because my phone just died, but I did plug it in and I'm back. So here we are. We were just about to move on to number 4. All right, number 4, this is the last one that we're doing together. You can kind of guess which condition this is going to be because we've already done 3 of the conditions, but that's okay. We're going to do it from scratch. All right, so here we are. We're going to isolate that absolute value sign, which means I have to divide by the -4 here. Oh, I think this was... Sorry. Oh, I went through my whole video without making a mistake, and there's my my mistake on the last problem. That's supposed to be, I'm looking at my notes, that's supposed to be a less than sign. All right, so I'm going to start off by dividing by a -4, and then when I go ahead and divide by negative, now that sign flips, and then now 12 divided by -4 is -3. Now, no matter what's in here, even though it looks like there's a negative in there, this answer will always be positive because it's an absolute value. So you have absolute value is greater than a negative number. When is a positive greater than a negative number? And that is all the time. That's all real numbers. But we're asked for our answers usually in that interval notation. So you're going to see negative infinity to positive infinity. And then just kind of look back at our conditions. That's condition 4 there. All right, so that's the last thing that we needed to do. I know I went through this review, kind of quickly. You could expect a little heavier emphasis on the questions. I think you guys benefit from seeing a lot of practice problems, especially when I allow you guys to, do a review before the assessment. I think it's a little helpful. But if you're really confused, I advise you go back and look at the other videos. Once again, your next assessment is on inverses and inequalities. You can find more information about your upcoming assessment in the description of your classwork with today's video. All right, thanks. Make sure you do your homework and email me if you have any questions or concerns.